Okay, so as we have seen here, we have seen so many things now. We have seen the first one is ST. ST is called the position. And then we have VT is the velocity. And then AT is acceleration. So once we have now the derivatives, S velocity is always equal to S prime t, which means the derivative of position, or ds dt. This is or. So velocity is ds dt. Acceleration is the derivative of velocity, so v prime t, or dv dt, or the second derivative of position, we write it as d2s dt squared. So acceleration is the second derivative of position. So let's see an example here. So a particle is moves in a straight line. So S position is in meters and T is in seconds. So it's modeled by St is equal to T cubed minus 6T squared plus 9T plus 5. A. Find velocity at T is equal to 4. Therefore, velocity is, as we have seen, the derivative of position. It is 3t squared minus 12t plus 9. We want the velocity at time equal to 4. 4 squared minus 12, 4 plus 9, which is 16 times 3 is 48, minus 48 plus 9. Which is equal to 9 meters per second. Find acceleration at t equal to 4, which means acceleration is the derivative of velocity, which is equal to 6t minus 12. Therefore, v prime at 4, 6 times 4 minus 12, which is 6 times 4, 24, 6 times 4, 24 minus 12, which is 12 meters per second square, because acceleration is meter per second, meter per second, which is meters per second square. When is the particle at rest? When is the particle at rest? When is the particle at rest means when is the velocity equal to 0, which means particle at rest means v equal to 0. Okay, so v must be equal to 0. The velocity must be equal to 0. Therefore, I have my velocity here, 3t squared minus 12t plus 9 equal to 0. I take the 3 out, t squared minus 4t plus 3 equal to 0. I factor this, t minus 3 and t minus 1 equal to 0. Therefore, t equal to 3 or t equal to 1. So the velocity is at rest when t equal to 3 seconds and t equal to 1 second. When does the particle move? When does the particle move on the right direction? When does the particle move on the right direction? So to do this, I have to have a chart using the points including 0. Therefore, I have a chart with t is 3, t minus 1, t minus 3, and we have the velocity. So we have 0 starting point, and then we have 1 second, and then we have 3 seconds. So I cannot have less than 0 because my domain is always t greater than or equal to 0. That's my domain. So I cannot have less than 0. So between 0 and 1, this will be negative, this will be positive, this will be positive, this will be negative, this will be negative, this will be positive. So it will be, this will be negative here at 0, this will be negative, and then negative times negative is positive. It will be positive here at that line. This will be positive, this will be negative, this will be positive. Therefore, right direction, the right direction will be when t is greater than 3 and t is between 0 is inclusive, less than 1. Between 0, because at 0 it's positive. 0 it's positive. Okay. Now let's see, in this part, which is E, draw on a number line the motion of the particle. Draw on a number line the motion of the particle. So what we have is, we have a number line which is ST. This is ST. So we have to find first S at 0. S at 0, S at 1, S at 3. We calculate those ones. S at 0 is equal to 5, S at 1 equal to 9, S at 3 is equal to 5. So number line for ST means I start with 0 here, I need 5 because there is 5 here on the number line, or S. Then we have around 9 here. So now we have the particle is going from 0 to 1. So we have 0 is, what's this 0 here? We have at t equal to 0, we have 5, t equal to 0. Then at t equal to 3, now we have 5. At t equal to 1, we have 1. So above 9, I write t equal to 1. Above 5, I write t equal to 0 and t equal to 3. So now let's go to our chart. Our chart is saying from 0 to 1, it's on the right direction. From 0 to 1. From 0 to 1, it is the right direction. Then from 1 to 3, it's to the left direction. 1, 2, 3. Then from 3 above, it is the right direction.